Hi everyone, and welcome to this second introductory video on mechanical vibrations. I hope that you managed to work yourself away through the kinematics, the world of coordinates and constraints, and now we will make the next step, and that is to the kinetics. So now we will actually start deriving the equations of motion of rigid multibody systems. So systems that consist of point masses or rigid bodies. And what you will see is that this is the point where we add the physics. So we will use Newton's second law, F equals m times a, as the governing equation for the physics. And we will see that using Newton's second law only, we are able to derive the equations of motion of systems that consist of point masses only. And after that, we will extend the Newton's equations to the so-called Newton-Euler equations, because Euler was the one who basically said how are we going to deal with rigid bodies and their rotation. And we will see that at that point we will add the moment balance, and we need to discuss a little bit the inertia properties of bodies. Okay, for this block I will need 5 lectures in total, 5 videos. 3 of them will be on point masses and the last 2 will be on rigid bodies. What you will see that in the process of deriving equations of motion, you will see that it is important that we are able to draw what are called free body diagrams. Now, well, probably you did this before many times, but we also need it here. So we isolate bodies or point masses, make a diagram in which we include all the forces acting on them, and use this as a starting point for the remainder of the derivation. Now, I think what you will also see from the second video lecture on, that the kinematics, what we did until now, is very useful. You will see that in some cases you will need additional equations. You are lacking equations if you only do force and moment balances, and that these missing equations are exactly the kinematic relations we have just derived. So that is very good. And I will also show you that based on the kinematic diagram that we learned how to draw in the previous lectures, that if you know how to do this, this will provide you sometimes with a shortcut in doing the derivation. So I will first present a general method that will always work. So if you just like one method that always works, I will explain you how to do that. But if you're very good and have some more insight in the motion of a system and you already drew the kinematic diagram, this will provide you with a shortcut, which is really nice because it will save you some time and some ink. So that is good. All right, so I will first do these 5 video lectures, 5 pencasts on the derivation of equations of motion. And after that, I will come back to you with the introductory video of the next topic. So keep up the good work, and I see you later. Bye-bye.